Thanks a lot for inviting me here, and thank you all for coming. As Reinhard mentioned, my point in being here is to try to present bits and evidence here and there that try to answer these questions. And he asked me to show a number of things, including to mention the World Conference on Research Integrity, from which we just came back. So I stuck it right at the beginning. This is the third World Conference that just happened. The first one only occurred less than 6 years ago in 2007. And so I think it's a good way to start, as it shows how the world is having an increasing interest in these problems. And it's a very recent thing. And so it's fair to ask if the recent interest comes from the fact that we're having a new problem. Because actually, as you're probably aware, it's not difficult to go back in the history of science and find illustrious names of scientists that probably did fudge a bit with their data. You have Gregor Mendel here, discoverer of the laws of genetics. You have Robert Millikan, who won the Nobel Prize for having measured the mass of the electron, and later people found that he was basically selecting his data points based on how good they looked. And Isaac Newton himself, who some say couldn't possibly have done some of the experiments he described. Even more interestingly, here and there, you find people in history that have lamented the same kinds of problems we'll be talking about tonight. Famously, Charles Babbage, who was a British mathematician, who wrote an essay on what he perceived to be a whole decline in the science in England. But he dedicated a chapter to specifically ways in which people would cheat or lie in science. But the truth is that I connect, at least, all this to the beginnings of science itself. If you go back to people like Francis Bacon, who philosophized about this new way of knowing, he famously talked about idols, which, and you see all these different kinds, which are essentially what today we call biases. And so I think this is really an important point that we should keep in mind at the beginning of the discussion that we'll be having tonight. Because to some extent, clearly what we're talking about is not new, and indeed, I would argue that it's physiological to science itself. And that's simply because science is made by people, and people are sometimes dishonest, but more often than not are just imperfect and biased. And indeed, if you think about the scientific method, what's the point about having a scientific system is having a set of rules that are there to make sure that you're not fooling yourself or you're not being fooled by others. And so what we're talking about here and what we're doing, and hopefully we'll do more and more in the future, is simply part of, I think, the scientific enterprise itself, and it's a never-ending process. Having said that, it's still a good question to ask whether we're having a recent problem that might be worsening, and we'll see some data on that. But what I think is really new nowadays is the fact that we're talking about these things so openly, and indeed that people like me and others take on this as a research topic in itself. This never happened before. You had historians or sociologists occasionally studying particular cases, but the general understanding until 20 or 30 years ago was that these problems were extremely rare and science was ultimately self-correcting anyway. So now let's get to a bit of data. Okay, I framed it around these three basic questions, okay, just to give it some kind of logic. And how is it done? Now, a lot of this literature that is growing on scientific misconduct consists in surveys. To a large extent, surveys asking scientists, anonymously of course, did you ever do this or that kind of behavior? I started the research that I do now by trying to put all this evidence together, which was all diverse and so difficult to sort of compare and make sense of, in a meta-analysis, which is a statistical technique by which you combine data from different studies on a specific question to get an overall picture. And so, for example, if you focus on self-reports, so surveys asking scientists literally, did you do this or that in the past X years, you see that overall, so if you're unfamiliar with how our meta-analysis works, so these will be different studies. This is the overall effect, which in our case is going to be the percentage of people that replied yes at least once. Okay, at least once they admitted to having done that. And the bar is a measure of uncertainty. And the size of the square is going to be proportional to the size of the study. And so you can kind of really see how, there is quite some difference between the available evidence. But overall, you get that about 2% of people scientists admit to having either fabricated, which means made up your data, falsified, or altered somehow their results. And if you limit the questions to incriminating words, specifically fabrication and falsification, you still get that about 1% across any survey replies yes. Having said that, you can see how the 95% confidence interval, which is roughly speaking where the true figure is most likely to lie, is somewhere between 0.3 and 3. So there is a significant uncertainty around these estimates, and we should probably talk about this more. Many more surveys asked, do you know a colleague that has done any of these behaviors? And there you get the 14% of people recall a case like that, and 12% if you limit to fabrication or falsification. There are good reasons to believe that this latter is an overestimate, but clearly the figures are higher than what I would guess most people might think. If you go into what are technically not even incriminating behaviors, but what fall into this gray area of practices that sometimes can lead to bias, such as dropping your data points or not publishing research because somehow you think it must be incorrect, then people admit to these behaviors a lot more. And you have that up to 34%, depending on the specific behavior and the specific survey, will admit to these. Up to 72% will admit to other behaviors, and coherently, if you like, you have questions that just lump a lot of different concepts in, and people agree with those more. So overall, the picture, I think, it's quite coherent and clear. So the first answer that comes from surveys, at least, is that it seems pretty clear that these behaviors can be characterized as lying along a continuum that would go from an ideal scientific practice to the most extreme forms of cheating, to use a colloquial term, and logic and this evidence at least would suggest that the bulk of the problem lies indeed in this gray area of conscious or even unconscious biases, which in my understanding is what we mostly want to discuss tonight, and it's an important thing to do. This is going to be the biggest part of the talk, because this is what a lot of people are trying to understand. Obviously, because they are aiming for finding solutions. Now, a first answer may come from the survey evidence I just showed you, because those surveys that asked, do you know a colleague, did you ever, let's summarize it in, did you ever suspect that misconduct had occurred? So in some cases would then follow up the question asking, well, what did you do about it? And again, the questions are rather different, so it's hard to put them all together, but coherently across these surveys, you get that in around half of the cases, nothing at all had been done. And in very few cases, people had followed a formal procedure of alerting authorities or taking similar actions. So a first answer to why is it done is that quite clearly it's easy to get away with it. Even if you're talking about the most extreme forms of misconduct in science, we know already that very few people will do anything about it, even when they have serious suspicions. But I think the real key point here, which is still under-discussed, is that there is a methodological dimension to it. And a lot of this will come from studies that I've done using a very simple proxy of bias, of publication bias, which consisted in sampling papers that declared to have tested a hypothesis, and then reading the abstract or sometimes the paper itself, finding out how many concluded to have found a support for the hypothesis. It's obviously a very indirect proxy of the problems we're talking about. On the other hand, whenever you're talking about fudging data, manipulating, fabricating your data, people don't do that to get a negative result, right? They're looking for some pattern to show as important. And from the beginning, a pattern that came out using this proxy and has been replicated quite a few times is the fact that, as you can see, when you move from the physical to the biological to the social sciences, you see the frequency of positive results increasing, okay? And you observe the same if you if you classify papers by methodology, as you see here. So this was what was actually measured in the outcome. And this would be behavioral studies on people, this would be behavioral studies on animals, and this would be purely physical chemical studies, so the hardest sciences, if you like. And again, it's stronger in pure disciplines and less in applied disciplines, but overall you see this increase. If you literally look at how journals where these papers were sampled from or classified, you see this pattern overall again. In particular, you can see how space science is arguably the best functioning science in that it has roughly 70% only of papers reporting a positive result, then the rest are essentially either falsifying an hypothesis, that is contradicting an hypothesis, or reporting a null finding. And at the other extreme, you have psychiatry and psychology, which instead has well over 90% positive results, which in scientific terms is close to an absurdity. Now, interestingly, I don't know if you followed the recent developments in psychology, but psychology has been hit by a tsunami, I would say, of embarrassment coming from the Dietrich Stapel fraud and other similar cases. And this paper actually came a year before all that happened. So actually, according to some, this was evidence anticipating the fact that this field has a bigger problem than others, which might be the case. So this, in my understanding, answers, again, the question in terms that it's easy to get away with it, but not just because people will not report really bad behaviors, but because in general terms, self-replication in science is not as efficient as we think. Very few people will actually try to replicate findings. They're all trying to prove something new. If they do replicate findings and find a null result because the study whose replication was attempted is false or falsified or fabricated, well, somehow they seem very unlikely to publish that result anyway. They will either not submit the results or turn them somehow into a positive finding by more or less questionable research practices that we saw, or they'll explain it away, again, working around the theory or reformulating the hypothesis once they saw the results. And the point is that you see these patterns arguably because, by definition, softer sciences like the social sciences and some biological sciences is where these kinds of behaviors are more likely to be enacted. A cause that is commonly discussed in the literature is pressures to publish, okay? And that's really the argument behind saying that we're having a bigger problem nowadays, the fact that scientists are increasingly under a competition, and it's a competition determined by how many papers you publish, where you publish, and so on. There is a basic prediction that you would make if that hypothesis is true, and that is that you would see a link between bias on the one hand and productivity on the other hand. If you look at papers published in the United States, which is what you have here, these are all states in the United States, and this is their frequencies of positive results, and this is how many papers per PhD in academia you get from these states, you do find this correlation. Now, this is far away from being a smoking gun or something, but it's a first indication that actually our concerns for this might be correct. Even more interestingly, connected to this is the fact that, again, this is the same proxy we talked about before. You see it increasing over the years in the scientific literature. Okay, here you're going from 1990 to 2007. But even more interestingly, it doesn't happen in all disciplines. So again, you have space science and a few other arguably hard sciences, including some in the biological sciences like plant and animal sciences, where you see no increase at all. Whereas in other cases, molecular biology has a record, but psychology and psychiatry does pretty well as well. You see a very sharp increase. So arguably, these would be disciplines where the problem is worse. And by the way, you see differences in countries as well. Now, I won't show you the data about increases in different countries. This is another study, but it did the same operation, this time sampling by country, taking the UK and the US and China and Japan and South Korea. Now, there are different reasons why these countries were chosen, but I think you might have heard how China seems to have a bigger problem with misconduct because of the particular system of publish or perish that they have there. And indeed, it does turn out that China has the highest frequency of positive results of all. So this again fits our predictions, if you like. Interestingly enough, though, the United States, which wasn't expected, have intermediate values between the UK, or in fact, all European countries and countries like China. And this, again, it's been replicated 2 or 3 times. And we're trying to understand why, but arguably this would suggest that maybe the US have more of a problem that they even realize. And, you know, there's other indications, and I think I'm already running out of time. So there are other indications that, for example, in long-distance collaborations, where arguably people are less likely to check upon each other's results, you get probably the higher problems. One thing I would like to point out is that there is independent evidence for what I just showed you. For example, there's this study in Scientometrics which used a different proxy, but similar to mine, and they found an increase in positive results in fact, several electronic databases they looked at. And there are at least a couple of studies that do suggest that studies from North America, for example, have a higher publication bias. So I'm not saying that this is conclusive results, but research, and hopefully there'll be more research, is kind of closing in on these forms of questions. And so, yeah, you know, the hypothesis that pressures to publish and professional pressures have something to do with it is quite plausible, and it's plausible that they have been recently increasing, and as I mentioned, that actually it might be worse in some countries. Now, the last thing I wanted to discuss is what can be done about it. I suppose this is probably going to be the point of the evening. We said that it's easy to get away with it. In my opinion, the only way to answer this ultimately is to reinforce the system, in particular, reinforce the system around the rules. I'm not a big fan of rules, but there is an amazing diversity in even the basics. This is how different countries define scientific misconduct. Okay, these are different countries, and these are the behaviors that are included in different definitions. And this is just an example. There would be many more even within the same country. And as you can see, they all share the fabrication, falsification, and plagiarism, which is the American standard that everybody is following nowadays. But then different countries, you see, they include different specifications. And similarly, another contentious area is whether you should consider misconduct only behaviors that are intentionally misleading or not. And again, you have different ways to frame this problem and in different countries. And so I think there's a lot of work to be done there to improve, to make clarity in the rules. And by the way, we mentioned the fact that people don't really report misconduct, so protecting whistleblowers and obviously educating and training scientists better. This is all things I agree with. I'm not really going to discuss. We saw that arguably there are greater pressures to publish, which might be having a negative influence. Here, it's the system itself that needs to be changed. Okay, the problem is that doing replication studies is not really rewarded. No one gets any credit for just having repeated someone else's study, even though that is the essence of science itself. And by the way, we still have this old-fashioned system in which you submit papers and journals will send them to peer reviewers who evaluate the whole work. Quite a few authors have suggested this, and I completely support it, that journals don't need to do that at all. They could just receive introduction and materials and methods and decide upon the quality of the work based only on that, and then leave the results to the scientific community to judge. And we said it's easy to get away with bias, and this is another element that I believe is severely under-discussed, and again, it's probably, in my opinion, the real key to solving these problems, which is about what you report in research. We said that replication is the pillar of good science. In order to be able to replicate results, you need to know how they were done, or even just to evaluate them critically, you need to know exactly what was done. And there's technically no rule to do that. There are initiatives like the Equator Network, for one, or MIBI, which is minimum information on, if I remember well, biomedical and biological investigations, which are trying to do that, which are trying to produce guidelines which say, if you're using this particular methodology, you need to specify what you did here, here, and here. And technically, I don't see any problem in having journals enforcing these rules upon authors, making sure that the literature is transparent. Because again, this is just the essence. And indeed, I have suggested a couple of times that we could make this the essence of our definition of scientific misconduct itself. And I'll leave it here for you to read. And thank you very much.